We have horizontal and vertical translations of functions. A transformation is any operation that moves or maps a figure from an original position to a new position. Transformations that we'll consider are translations, reflections, and stretches. Translations. A translation is a transformation that slides each point of a figure the same distance in the same direction. So last year you were taught this. You were taught that if h, and I don't know if we use p's or h's, depends on teacher, but either way, if h is positive, you actually move to the right. If h is negative, you move to the left. And remember, it was always the opposite sign, right? So if you had, it's because the formula has a hidden minus sign in it. So if you actually had like y equals x plus 3 squared minus 7, you moved 3 to the left. And the reason why that was, as a reminder, is you have that minus sign in there. So this is actually x minus a minus 3. That would make that plus, right? So the reason why you're moving to the left is because it's actually a minus 3. Right? That's why you move to the left. Not just memorizing, you move to the left when it's opposite. You move to the left because it's a minus, which actually makes it a plus. Because the formula has a minus in it. Okay? Then, when it's a minus, say x minus 3 squared plus minus 7, then that would be x equals x minus positive 3 squared minus 7. Thank you. You're the bomb.com. I just recorded that. Mrs. Wade's awesome.
Hi, whoever I'm talking to.
Okay, so in this one you'd have minus a plus 3 squared. So then it would actually be to the right. Correct? So that's why it's the opposite, not just because it is the opposite. There's a reason. Therefore, when this is a plus k at the back, is that a minus k? No, it's a plus k, so we just do what it says, right? So in this case, I would move down 7. Here, I would also move down 7, right? So when you move it all to y equals function, if it's a minus with the x, it's to the right. If it's a minus with the x, or a plus with the x, it's to the left. But your k is always the right direction because there's no hidden minus sign in there. And it's either up or down, right? We did that last year. Now, we're going to do, it's like we take last year and then we just like trump it up, you know, like make it like hardcore. That's what we do. We just take last year's transformations and hardcore it. That's what we do. Okay? So, when we do the wording, when we write like vertical translation 7 up, we have to write vertical translation 7 up. We can't just write 7 up. We can't just write it in a different order. We can't write it short form. None of that is an option. Why? Because I don't mark your diploma, right? Someone is marking your diploma and they're looking for vertical translation 7 up. If it's not in that form, you will not get the marks. Okay, guys? It has to be that form. That is how it is. Horizontal translation 3 left has to be written that way. Okay? Left 3, they still give it to you. It's not like that's, but you have to have all those words. Same as the horizontal translation. That means it's moving horizontally 3 to the left, or left 3. So far. Okay? You're just explaining what's happening. So, mapping and replacement notation. For mapping is huge in grade 12. Mapping is literally like you write what the point, how the point is going to move with variables. Okay? So that you can move any point you want. So if I looked at this one and I rewrote it because I was writing in y equals, it'd be y equals f x minus h plus k. Now you're going to see this f a lot. All that f means is this represents a transformation on a function. The function could look like this. Last year it had to be quadratic, right? So it'd be a quadratic and then you move it to a new quadratic, right? It'd be x squared and then you just change it. This year, I could give you this. We're not drawing this, but I could. It's a function. It passes the vertical line test, but there's no equation to it. So last year what some people would do when they didn't know the transformation is they type it into the y equals and see what it did, and then explain it that way. This takes away that fact. You can't plug this into your calculator. There's no equation that represents that. So they'll just make you move that graph. So that actually checks if you do know what you're doing. Do you know how to move the graph? Not your calculator knows how to move it and you just copy it off. okay? So they could represent this as y equals f of x, right? And now this is just, hey, this graph up here moves h to the right and k up. So that's where that f comes in. This is f of x, and now I'm applying horizontal and vertical translation. So that's what that little f means, okay? It correlates with another function. Now, this means I move right h, up k, right? Horizontal translation, h right, vertical translation, k up. So if I'm moving right, my coordinate, which used to be x, y, if I'm moving h right, what am I doing? I'm adding h to the x or y? The x, because the x is the one that moves this way, right? If I'm moving h right, I'm adding h to the x. If I'm moving k up, I'm taking that y wherever it was and I'm adding k to it. So that's your mapping. Why would we want mapping? Because now I can take this mapping and I can apply it to anything to move points. So you use mapping when you're moving coordinates. So when you have a single coordinate, they sometimes ask you, or if you have a graph and you need to move it, you're going to use mapping every single time. And then there's replacement notation. Replacement notation is when you say what you're going to replace the x with. So the original function is this, y equals f of x, right? They're going to say, okay, I'm going to take this x here, I'm going to huck it behind my head, and I'm going to replace it with x plus h. So I go here, I huck the x out, and I replace it with x plus h. That's what replacement notation is. Then here, I'm going to go to my y, and I'm going to replace it with y minus k over here. What does that y minus k mean? I'm moving k what? I'm moving k up or down? Up, because it's not with the, it's with the y currently, isn't it? You guys have always dealt with it on the right-hand side. That's not the case anymore. It can all be on the left, and you can move it to the right. So whenever it's with your variable, you do the opposite. So h is always going to be with x, so we're always going to do the opposite. In this case, k is with my y, isn't it? So I'm going to do the opposite. If it's minus k, it's actually moving k up. Why is that? Because I need to move the k over. When I move the k over, it's a plus k. So it's always in your best interest to just get it in y equals every single time. If it's not in y equals, I move it to y equals. So we have the graph of y equals f of x is transformed to y minus 2 equals f of x minus 3. So let's do replacement notation first. The y is being replaced with y minus 2. And you're not just replacing minus 2, you're taking that y, completely throwing it out, and fully replacing it with y minus 2, right? And then we have x, and it's being replaced with x minus 3. So you put the arrow, because that's showing replacement. X becomes x minus 3. Y becomes y minus 2. Now, in order to give the other ones, I'm going to actually write it in y equals. So if I wanted to write out my transformations properly, I would say vertical translation to what? Up. And a horizontal translation three right. This is a unit you need to keep up with as well, because for two reasons. I can ask mapping, I can ask replacement notation, I can ask equations, right? I can ask it of any function. So at first it seems really easy, and then if reflections comes on, it's still easy. Stretches on, it's okay. And then I put them all together and you get overwhelmed. So if you keep up with them as we teach, like the translations first, then the reflections, then the stretches. Then when we put them all together, you're not overwhelmed. But if you don't keep up with it, once they're all together, it's super overwhelming. The other reason why transformations is so important is it comes up in every single unit until the end. Every unit from now until the very end, transformations is going to be in it. It's part of it. So it doesn't go away. Like perms and cons, here it is. And they'll come up on your cumulatives, but it doesn't come up in this unit, right? Transformations, we do it second. We do perms and cons first so that you have lots of practice for the diploma. We do transformation second because it comes up in every single unit. We can't actually do any other unit until we've learned transformations. So it doesn't go away. So if you're like, oh, I can't wait for this unit to be over. It's over, but it never goes away. It's underlying all the time. And usually by the end of the year, you're like, why did I ever find that hard? It's so easy. Because you've done it so much that it's literally just part of you. Okay? So if we do mapping, mapping originally was X, Y. Mapping and words, these are BFFs. They're just two separate ways. I always do this. Mapping, words. They're the same. They're in love. They're just two separate ways of explaining the exact same thing, right? So this one here, I said horizontal translation 2 up, or vertical translation 2 up, horizontal translation 3 right. Here I'm just saying horizontal translation 3 right. I'm adding 3. Vertical translation 2 up. I'm adding 2. Why do I say mapping and words are the same? Because right now you're like, of course they are. And then I give them to you and you guys flip these all the time. Don't flip them, right? When you get your words, you can do mapping instantly. When you have mapping, you can do your words because they're the exact same thing. In your equation, the X switches, correct? The X switches in your equation. But between mapping and words, it doesn't because they're just two different ways of explaining the same thing. It's like I could explain what we're going to do with our translations here, or I can give you mapping and explain it to you. I have two different ways to explain the exact same thing. So your signs don't change or anything, right? They're the same. Because if I'm moving 2 right, I have to take my X and I have to add 2 to it. If I'm moving 3 up, or 3 right, I can take my X and move it 3 to the right. If I'm moving 2 up, I take my Y and I move it 2 up. How do I do that? I add 2 to it. So these are the exact same thing. Okay? So when do I use mapping? So they say, so if the point 4, 6 is on f of x, then the point 7, 8 would become, or then the point would become 7, 8 on this equation. That's what it's saying. So if we're moving a point on the original, if ever we move a point, we can use mapping. So we can go xy becomes x plus 3, y plus 2. That's mapping. This is my original, and this is my transformed. Okay? So my original is 4, 6. And then I apply it to get my transformed point. 4 plus 3, 6 plus 2, and my new point is 7, 8. Now mapping, I'll see people just write x plus 3, y plus 2. That's their mapping. Mapping is, I have a point, it becomes this point. So if they ask for mapping on a diploma, you have to show this whole thing. You're saying this original point becomes this point. Okay? If you don't do that, you're not showing mapping, and you're not going to get any marks. Since it's a mapping question. So you must show original point becomes new point. Next page. So here we're going to describe how the graphs of the following relate. So we're going to state our transformations. And they're relating to the graph y equals f of x. So the y is here, the f is here, the x is here. So if I have y, f, and x, those are perfectly fine. No transformations have happened to them. Those were on the original, right? The only thing that's new is this minus 3. And what does that mean? What kind of transformation is that? Yeah, we have to say, before that though, we have to say horizontal translation 3 right. You guys do B, C. B, what are we going to write? Is it vertical or horizontal? Vertical, because it's not with the X, right? So it's a vertical translation. I froze the board. Translation 4 up. Please don't use VT. No one knows what that is. Vertical translation. You need to write vertical translation, okay? This one is a vertical translation. Eight down. This one's a vertical translation for what? And a horizontal translation. Example 2, what happens to the graph of the function y equals f of x if the following changes are made to the equation? So we're using replacement, replacing x with x plus 2. So we're going to get y equals f, and instead of the x, we're going to take that x, we're going to huck it behind our head, and we're going to replace it with x plus 2. What happens then? What kind of translation? Zach? What kind of translation? 2 to the? This one we're replacing the y with y minus 8. So we're going to get y minus 8 equals f of x. So that's a vertical translation 8 what? Up. Because we can add the 8 over. This one, the point 2, negative 3 lies on the graph of y equals f of x. State the coordinates of the image point under the following transformations. If we're moving a coordinate, we do mapping. Which is what you do. It should be part of your head. You move a coordinate, you do mapping. Okay? So we're moving a coordinate, we're going to do mapping. I'm going to add the 8 over. I'm going to add the 8 over. Oh my gosh. I'm going to subtract the 8 over. So I get y equals f of x minus 8. So what am I doing? It's a vertical translation, 8 down. We agree? And you might think, why am I doing mapping now? It's so easy. You're doing mapping now because you're going to have to do mapping later when it's not so easy. When you have all of the transformations and stretches and reflections all together. Okay? So we're going to practice mapping now, even if you can just move that 8 down and say it's negative 11. Okay? So we're going to go mapping. We're going to go x, y becomes, did anything happen to my x? Nope. And my y moved 8 down. So how do I move y 8 down? Subtract 8, right? Remember, words and mapping, same thing? Best friends? So I'm going to put my coordinate in. I'm now going to go 2, 3. 2, negative 3, sorry. Becomes 2, comma, negative 3 minus 8. So what's my new coordinate? 2 and negative 11. Now, would I have had to have done mapping if it was just 8 down? I moved the negative 3, 8 down, and it's negative 11? No. Are we still going to do mapping every single time we're moving a coordinate, though? Yes, because we're practicing for when we get more stuff to add to that mapping. Because we'll have a stretch, a reflection, a translation on the x, and a stretch, a reflection, a translation on the y. Way more complicated later. Okay, you try this one out. And then I want you to do example 4. So you're doing example 3b and example 4. So this one we're moving 7 to the right and 5 up. So we're going to get xy becomes x plus 7 to move it 7 to the right, y plus 5 to move it 5 up. Because mapping in words is the same. I move my coordinate 2, negative 3 becomes 2 plus 7, negative 3 plus 5. So it becomes 9, comma 2. Remember, words and mapping are the same, right? If you can remember words and mapping in a heart, your test will be substantially better. The people who I find write words and mapping with a heart on their test actually do better. And I'm not joking, because I think that that makes them remember that they're the same. I see it all the time. Okay. Write the equation of an image of y equals f of x after each transformation. So we're going 5 to the left. So we're going to get y equals f x plus 5. It's the opposite. In vertical translation, 3 up. Y equals f of x plus 3. Or you could have written y minus 3 equals f of x. Same thing, right? C, a horizontal translation, m right. You're going to get y equals f x minus m and p down minus p, or y equals f of x minus, y plus p, right? Y plus p equals f of x minus m. Which one's more correct? The one that's on your test. That's the one that's more correct. It's not more correct, it's the only one that's right. They're both equally as good. Okay? So if we saw it on the diploma, unless set in the form y equals, then either one would be sufficient. Next page. We're moving lots of coordinates now. It says, in each case, the graph of y equals f of x is shown. Sketch the following transformations for each case. Y equals f of x minus 2. I'm now, when I look at a graph, a graph is just a whole lot of coordinates, right? Connected together. Infinitely connected with a domain. Restricted between these values. So, I want to move this coordinate, this coordinate, this coordinate, this coordinate, this coordinate. I have to move 2 to the right. So could I just do this? Could I go, okay, 2 to the right. 2 to the right. What I suggest is do your points in order, first off. Second off, when you make 2 points, connect them. Because what happens is people will make a whole bunch of points and then randomly connect them wrong. Okay? Do point to point, connect. Point to point, connect. Point to point, connect. Carry on. Like I said, this is a little more obvious. I'm just moving it 2 to the right. It needs to look the same. But what happens when I add stretches and reflections and translations to it? Then you won't know. So always do it in sequential order. This one's 2 to the right, so it's here now. That one's 2 to the right, so it's here now. This one's 2 to the right, so it's here now. So that could have been done without mapping, right? Pretty easy move. The next one we're going to do with mapping because I need you to get used to mapping. Because it's easy when it's like this, but they're not going to give you questions like this. They're going to give you questions with stretches, reflections, and translation. And that's when you need your mapping. So, I'm going to move my 2 over. So what's my mapping then? X, y becomes what? X, what 3? Minus 3, because we're moving 3 to the left, and the only way you can move coordinate 3 to the left is by subtracting 3 off of it. Y, and now I need to go down 2. What's the only way I can go down 2 from a y coordinate? Subtract 2, right? Now you're going to do every point. So I'm going to take the coordinate 1, 2, 3, 4, 5, 6, 7, negative 7 and 2, and I'm going to plug it in. Becomes negative 7 minus 3, 2 minus 2. So it's going to become negative 10 and 0. Plot new point. Ooh. Then I'm going to do mapping with the next point, the next point, the next point, the next point. Okay? You go do that. Could I just go 2 left and 3 down, or 3 left and 2 down? Absolutely. Do I want you to do that? No, I want you to practice mapping for later when it's way clear. Okay? I'm going to need practicing when it's easy. So try that out.